So we have a Rice Lake type S load cell. It is a 500-pound type S or S-type load cell. Its load cell output is 3.002 millivolts per volt. And it has a class 3 accuracy class along with a NTEP certificate of conformance. But yes, it's also factory mutual approved. So we have a load cell. We know its capacity. We don't know its color code. We don't have a data sheet for the load cell. So let's figure out the color code first, and then we will see if the cell is good or bad or what we can make of it. So we have a zip tie on our wires. So we have 4 colors. We know that black is almost always 99 out of 100, maybe 999 times out of 1,000 negative excitation. But we are going to go through and determine that. So our meter's set to resistance. We're set to the omega, which is resistance. So we're going to measure between black, and we're going to find the highest resistance, and that will be our excitation pair. So black to white, 300 ohms. Black to red, 382. Black to green, so 300 black to green. So between black and red, we have our highest resistance, so we will call that our excitation. So between any excitation and any signal, we should have the exact same resistance, plus or minus 3-4 ohms. So negative excitation to positive signal, 300. Negative excitation and negative signal, 300. And we will go to positive excitation to negative signal, 300. The positive signal, we have 300. So our cell has a balanced bridge. So far this cell looks good, and we now know the color code. So we will hook up excitation voltage to it. So on our power supply, we have 10 volts excitation. So red, which is our positive clip, goes on positive excitation. Black, which is our negative clip, goes on negative excitation. So now we're going to put our meter in DC millivolts, and we are going to put our positive on what we believe is usually positive signal, and then negative on what we believe is our negative signal. Okay, we have 0 millivolts. So with the load cell in our hand, with no load applied to it, we should have the 0 millivolts. So this cell so far looks good. Let us squeeze this load cell and see if we can apply any type of load to it to see if we can get a change in millivolts. So squeezing. All right, so I'm getting a negative change. Oh, okay, so I'm applying compression to it, and I'm getting a negative change in millivolts. So this S-type load cell works off of tension. So by pulling it apart, we get a positive millivolt change. By squishing it together, we get a negative millivolt change. So this seems to be working. We apply a compression load to it, we go more negative. If we apply a tension load to it, we go more positive. We figured out the color code. We know the color code. Everything else is labeled on the load cell, and we are getting 0 millivolts DC at no load with 10 volt excitation applied to it. So this cell looks like a good cell.